So, how do you stop your service from getting totally overwhelmed but still let legitimate traffic come through in healthy bursts? Well, today, we're going to break down two incredibly smart and powerful algorithms that do exactly that.
All right, let's just jump right in. Imagine this, your app, your service. It just goes viral. Awesome, right? But then, bam, requests are flooding your servers from all over the world. Without a defense mechanism, you are heading straight for a total system meltdown. And that problem, that's what rate limiting is all about solving.
The answer is something called rate limiting. You can think of it like a super efficient bouncer at the door of your club, or maybe a traffic cop for your whole system. It's there to protect you from getting overloaded. And the two go-to industry standard ways to do this are the token bucket and the leaky bucket. Let's dig into how they actually work. Okay, first up, we've got the token bucket. I love calling this one the Sprinter because it's built for speed. It's designed to handle quick, powerful bursts of activity while still making sure the long-term average pace doesn't get out of control.
You know, the easiest way to wrap your head around this is to think of it like a wallet. You've got a steady income. Let's say you get a few tokens added to your wallet every second. Now, every single request that your system handles costs you one token. If you've been saving up, you can go on a big spending spree. That's your burst. But once that wallet is empty, sorry, you're cut off. You've got to wait for your next paycheck.
So let's walk through how this actually plays out. Your system boots up with a full bucket of tokens. Then, a sudden wave of requests hits. No problem, it instantly spends those saved up tokens. After that initial burst, though, the bucket starts refilling at a slow, steady rate. Any new requests that show up now, they have to get in line and wait for new tokens to drip in.
And this brings us to the first really important dial you can turn, B, which stands for bucket capacity. This number sets the absolute maximum burst size your system can handle. In our wallet analogy, it's literally how much cash you can stuff into your wallet for that shopping spree. A bigger B means you can handle a bigger burst. Simple as that. And the second dial is R, the refill rate. So if B is the size of your wallet, R is your steady income. It controls the long-term average rate of requests your system can sustain. And it's the combination of B and R that gives you this amazing fine-grained control over both short-term bursts and long-term throughput. All right, let's switch gears and meet our second algorithm, the leaky bucket. Now, if the token bucket is a sprinter, the leaky bucket is a marathon runner. This one is all about consistency, stability, and just maintaining a super steady, predictable pace no matter what you throw at it.
For this one, I want you to picture an actual bucket. A bucket of water, and it's got a tiny little hole in the bottom, so water is dripping out at a perfectly constant rate. The incoming requests, they're like water being poured into the top of this bucket. Sometimes it's a trickle, other times someone's dumping a whole gallon in at once.
But here's the thing, it doesn't matter how chaotically water gets poured in, it only ever leaks out at that fixed, constant rate. And here's the really critical part. If a sudden flood of water comes in that would make the bucket overflow, that water is just gone. It's spilled on the floor. Those requests get rejected. The result is that the stream coming out the bottom is always perfectly smooth, completely protecting whatever is downstream from the chaos at the input. All right, so we've got our sprinter and our marathon runner. Let's put them side by side in a head-to-head showdown and really zero in on the fundamental difference in how they handle traffic. This right here is the heart of it all. It's the core trade-off. The token bucket is designed to allow bursts by letting you spend those saved-up tokens. This makes your service feel really responsive, but it also means the traffic coming out the other side can be just as bursty. The leaky bucket is the exact opposite. It's designed to absorb and smooth out those bursts, guaranteeing a steady, constant rate output. Now, when we look at the policer versions, the ones that just drop excess requests, you might notice the table says leaky bucket's output can also be potentially bursty. And you might think, wait, what? I thought it was a smooth stream. Well, here's why. If traffic shows up in little bursts that don't threaten to overflow the bucket, they'll just pass right through. The real smoothing effect kicks in when you hit that hard capacity limit. And this is what makes them perfect for different jobs. Token bucket is great for APIs that need to feel fast, while leaky bucket is for when you need strict, no exceptions traffic enforcement. Okay, now for what I think is the coolest part. One of the most incredible things about both of these algorithms is just how unbelievably fast they are. I mean, they are ridiculously efficient. It's why they are used literally everywhere, from the network card in your laptop to the biggest cloud services on the entire planet. This crazy efficiency has a name you might hear in computer science: O1, or constant time. Don't let the fancy term scare you. All it means is that the time it takes to decide yes or no for a request never changes. It doesn't matter if you have 10 requests a second or 10 million. The calculation is always, always lightning fast.
So, how is that even possible? What's the secret sauce? Well, it's because the algorithm is really simple. It doesn't need to look at a huge history of past requests. All it needs to know is two things: how many tokens are in the bucket right now, and when did the last request come in? That's it. From just those two numbers, it can instantly figure out how many new tokens to add and decide if this new request gets to pass. But, going from a cool idea on a whiteboard to a rock-solid system in the real world, that's where the tricky stuff happens. For example, what happens if your server's clock suddenly jumps backwards by a few seconds? It happens. If your code isn't ready for that, it could get totally confused. Real-world implementations have to guard against this, often by using a special kind of clock that is guaranteed to only ever move forward.
And that's not the only thing that can bite you. Tiny little rounding errors in your math over millions and millions of requests can actually add up and cause your rate limiter to drift. And of course, there's the basics, like making sure you check your inputs. A negative bucket size or refill rate doesn't make any sense, but if your code doesn't check for it, you're going to have a bad day. Okay, so we've covered a lot of the theory. Let's get down to the practical stuff. As a system designer, you're looking at these two tools. How do you pick the right one for the job? Here's the playbook, plain and simple. You use the token bucket when you want your service to feel zippy and responsive to the user. You let them have those quick bursts of activity, but you still put a cap on the long-term average. This is perfect for most APIs that people interact with directly. On the flip side, you choose the leaky bucket when the system downstream, like a database or some piece of hardware, just can't handle sudden spikes. It needs a smooth, steady diet of requests to work properly. So now you've got the two fundamental patterns in your toolkit. You can either allow bursts or you can smooth them out. But here's the next level challenge I'm going to leave you with to chew on. How would you take these ideas and build a system that can enforce unique limits, not just for one server, but across a massive global system for millions of individual users at the same time? That, my friends, is where the real fun begins.